Hello and welcome to IP lesson. In this lesson, we will learn about Layer 2 Etherchannel. Let's take a look at our example in order to understand what is the Etherchannel and what it does in our network. In our network here, we have switch 1 and switch 2. Those two switches are distribution switches. Each switch of those two switches are connected to 3 switches. We have 4 links connected between the 2 switches. What will happen for the 4 links that are connected between our 2 switches? So spanning tree protocol will run the STA, the spanning tree algorithm, and it will block 3 links from those 4 links. So this can be acceptable for access switches. I'm talking about the 3 switches that is connected to switch 1 or switch 2. It's not gonna be a big deal if that blocking happen on the access switches. But for distribution switches, we need to transfer data from the access switches, from the switches connected to switch 1 to the switches that are connected to switch 2. So as you can see, all the data will go through the link on interface fast Ethernet 0/1. There will be a lot of load on that interface. And this link by itself cannot handle that much data that will be transferred between switch 1 and switch 2. So we can implement Etherchannel in our network in order to take advantage of all those links and be able to transfer data through all those 4 links. So Etherchannel allow multiple ports to virtually combine in one logical link. Some people also call the Etherchannel ported channel, channel group, and link aggregation. Etherchannel support up to 8 links. So if we have more than those 4 links, if we have 8 links, we can combine those 8 links to one logical link. The benefits of Etherchannel is that allow us to have load balancing, redundancy, and it increase bandwidth. We can refer to the Etherchannel with this circle. So when you see this symbol, you should know right away that this is an Etherchannel. After deploying the Etherchannel, our switches will consider those 4 links as one link. So what is the load balancing? Load balancing is the process of distributing traffic among multiple network devices to improve a service or application performance. So before deploying the Etherchannel in our network, the traffic will go through interface fast Ethernet 1. After deploying the Etherchannel, the traffic will go through the link on interface fast Ethernet 1, 2, 3, and 4. For example, first packet will go through interface fast Ethernet 1, the second packet will go through interface 2, the third packet will go through interface 3, and the fourth packet will go through interface fast Ethernet 4. So this is called load balancing. After deploying the Etherchannel, we have to be very careful when we do modification to our interfaces. So after we deploy the Etherchannel in our network, for example, if we change the interfaces from fast Ethernet 1 to fast Ethernet 4, and we make all those links in one Etherchannel, for example, PO1, PO stand for ported channel, so those interfaces become ported channel 1. If we need to do any modification, we cannot do it on any of those interfaces. We cannot do it on interface fast Ethernet 1 or 2 or 3 or 4. Instead, we can do the modification on ported channel 1. If we did any modification on a single interface, it can bring our ported channel down. For example, if we need to shut down ported channel 1, we have to go to the ported channel sub-configuration mode and then enter the command shutdown. This command will shut down interface fast Ethernet 1, 2, 3, and 4. So it shut down all the interfaces in our ported channel. After we deploy the Etherchannel in our network, we will have the advantage of distributing the traffic through the 4 links, and also we will load balance the traffic through those 4 links. In order to configure the Etherchannel in our network, there is some requirements for the interfaces that will participate on the Etherchannel. So the first thing is the same speed. We cannot configure the Etherchannel on interface fast Ethernet and the other side be a gig interface, for example. So the interfaces have to have the same speed. The interfaces have to have the same duplex, same switch port configuration, same VLAN in case of VLAN, same allowed VLAN in case of trunk, same encapsulation in case of trunk, and the same STP configuration. Let's take a look at our example here in order to understand what we mean by that. If we need to configure Ethernet channel in the 4 links between those 2 switches, and we configure one side with VLAN 2 and the full duplex, and on the other side, we configure those interfaces with VLAN 3 and have duplex. This will cause for our Ethernet channel not to work. So this configuration cannot work for Ethernet channel, and the Ethernet channel will not work in that case. The reason of that, because we have VLAN mismatch. So one side configured with VLAN 2 and the other side configured with VLAN 3. And also we have a duplex mismatch. One side configured with full duplex and the other side configured with half duplex. So here another example. In our example, both sides configured with VLAN 2 full duplex and the speed is auto. The result of that our Ethernet channel will work and we will not have any issue deploying our Ethernet channel. To configure the Ethernet channel, we have to be on the interface subconfiguration mode, and then the commands that we will use, channel group, and then put number, mode on. The number here doesn't matter. So for example, if we configure group 1 on switch 1 and the group 2 for switch 2, it will work, but it's recommended to have the same number on both switches. This is our lab, and let's configure the Ethernet channel in our network. Let's start with switch 1, enable, conft. Instead of configuring interfaces individually, I will do the command interface range. Interface range fast Ethernet 0/1 to 4 channel group 1 mode, and let's do a question mark here. And as you can see, there is multiple options. The reason of that because we can configure the Ethernet channel dynamically or statically. So before we put our command, let's take a look again at our topology. And as you can see, spanning tree protocol lock 3 links out of our 4 links. So let's put the command on. Let's go to switch 2. In switch 2, enable conft interface range fast Ethernet 0/1 to interface 4 channel group 1 mode on. Let's speed up the time, and as you can see, our Ethernet channel is up and running right now, and there is no blocking in our network. After configuring the Ethernet channel, we will see PO1. PO1 refer to port channel 1, and the PO1 will refer to interface fast Ethernet 0/1, interface fast Ethernet 0/2, interface fast Ethernet 0/3, and the interface fast Ethernet 0/4. If we did show interface status, it will show us port channel 1 and the information about port channel 1. If we also did show VLAN brief, it will show us port channel 1, and the show spanning tree right now will show us port channel 1. So let's do those commands first. So right now I am in switch 2. Let's do the command show interface status, show interface status, and the first line give me information about port channel 1. Let's do the command show VLAN brief, show VLAN brief, and here it give me information about port channel 1. Let's do the command show spanning tree, show spanning tree. And as you can see, spanning tree protocol treat the interfaces fast Ethernet 0/1, 2, 3, and 4 as a one interface and refer to that interface as a port channel 1. It also changes the cost for the ported channel. So right now, our switch considered those 4 links as a one link. Let's check the ported channel itself by the command show Etherchannel channel summary. Show Etherchannel channel summary. And here it gives me a lot of information about the Etherchannel channel. Let's take a deep look on the show Etherchannel channel summary command. The first section show us the flags. So for example, capital D refer to down, capital P refer to in port channel, and so on. The total number of channel groups in use is 1, number of aggregators is 1, and after that we have group 1, port channel 1, S here mean that this is a layer 2 Etherchannel channel. Capital U here refer to in use. So if we have a capital D, for example, instead of capital U, this will refer that the Etherchannel channel is down, and the interfaces that is in port channel 1 is fast Ethernet 1, 2, 3, and 4. Capital P here refers at this interface in ported channel. We can also do the command show Etherchannel ported channel to verify our Etherchannel. So let's do this command, enable show Etherchannel ported channel. And this command give us the total group number, what is the ported channel group that we have, the age time of Etherchannel, the logical ports, the total number of physical ports, and also it give us information about the interfaces that participate on the Etherchannel. The next task that we have in our lab is to change the switch port from access port to a trunk port. So we have to go to interface ported channel 1 sub-configuration mode and do the command switch port trunk encapsulation.1q switch port mode trunk. We have to repeat this at the second switch. So let's do this command on switch 1 first. Enable conft interface ported channel 1 switch port trunk encapsulation .1q switch port mode trunk. I'm gonna do the same commands in switch 2. So after configuring switch 2, let's verify that the trunk port is working properly now. Enable show interfaces trunk, and as you can see, ported channel 1 is on trunk right now. The mode is on. The encapsulation is 822.1q, the status is trunking, and the native VLAN is 1. When configuring the Etherchannel, we can configure it dynamically or statically. So the command that we used on our lab, channel group 1 mode on, this was the way to configure the Etherchannel statically, and in that case, there will be no negotiation between each side. We can also configure the Etherchannel dynamically using a protocol called PAGP. PAGP stands for Port Aggregation Protocol. This protocol is Cisco proprietary, which means that we cannot configure this protocol in any device except Cisco. If we use the PAGP protocol, the interfaces will negotiate the Etherchannel. So instead of using the command channel group 1 mode on to configure the PAGP, we can use the command channel group 1 mode, and then we can choose desirable or auto. We have another dynamic Etherchannel protocol, which is LACP. LACP stands for Link Aggregation Control Protocol. This is a standard protocol, which means we can configure it in any network device created by IEEE. The standard name is 802.3AD. The interfaces will negotiate the Etherchannel when using the LACP, and the command also will be channel group and put the group number. Mode, we can choose active or passive. The channel group command will be under the interface sub-configuration mode. When configuring Etherchannel between two switches, we have to be very careful in order to configure the Etherchannel properly. So first, if we use on mean there is no negotiation and the interface will statically be an Etherchannel. So if we configure the on one side, the other side should be on in order to establish the Etherchannel. But if we configure on in one side and the other side we configure it with one of the dynamic Etherchannel options, there will be no establishment for our Etherchannel. If we would like to configure the LACP, the Link Aggregation Control Protocol, one side should be active. And the reason of that, because the active side will actively ask the other side to become Etherchannel. Same thing for PAGP. For Port Aggregation Protocol, desirable will actively ask the other side to become an Etherchannel, but passive for LACP will wait passively for the other side to ask to become an Etherchannel. Same thing with auto. When configuring the Etherchannel, we have the option to choose the load balancing that we want to use in our Etherchannel. So the command will be ported channel load balance, and then choose the load balancing option that we need to configure for our Etherchannel. For example, we can choose source MAC address, we can choose destination MAC address, and also we can choose source and destination MAC address. We can choose source IP address, destination IP address, source and destination IP address. We can also choose source port, destination port, or source and destination port. This is the end for this video. Thank you for watching and see you in the next one.